Hi class, today I'll be delving into the various ways that renewable energy can be stored with a keen eye towards underground gravity battery storage. In the face of fossil fuel domination, and with that, as we all know, environmental degradation, we can be thankful technologies in renewable energy are on the rise. The standard bearers include hydropower, solar, wind, geothermal, tidal and wave, and biomass to name, well, most of them. All are not without their own issues though. In some cases, they are dependent upon location, weather, and time of day, all of which leads us to a slightly bigger issue, and perhaps an even bigger issue. Just recently, Spain and Portugal suffered an unprecedented power outage, and while some opportunists have decided to put the blame on renewables and net zero emission targets in an attempt to fatten their own pockets, the reality is that we are in need of more renewable energy, or rather, a means to have an ample supply on hand in case of emergencies or the inevitable spikes, or in some cases, drastic drops in energy use. With a relative never-ending supply of energy, the question becomes how to harness it effectively for distribution across the grid. Well, yes and no. The solution comes in many forms, with a magic formula consisting of a low-cost implementation combined with a long lifespan capable of charging and discharging thousands of times, all while being safe and with an ability to store enough energy to be discharged cost effectively to match demand. In development are such technologies as compressed air energy storage, flow batteries, and as I've already mentioned, the one I'll be focusing on, storage through the use of gravitational energy storage systems or mechanical gravity energy storage. The concept of a gravity battery isn't exactly new technology. The idea is found in pumped storage hydropower, or more commonly hydroelectric power, as the water traveling downward is in itself a form of stored energy, which when used to turn motors or turbines converts the potential energy of the water at higher levels to usable energy. In the formula for potential energy noted here, U is the gravitational potential energy, M is the mass of the object, G is the acceleration due to gravity. Here on Earth we're talking about 9.8 meters per second squared, and H is equal to the initial height minus the final height of an object. The change of energy directly correlates to the vertical displacement of a mass. The higher a mass is lifted, the more gravitational potential energy is stored. The change in energy also directly correlates to the mass of an object. The heavier the mass, the bigger the change in energy. If one is unable to build by a mountain in several large bodies of water, and by large I mean reservoirs roughly the size of 30,000 Olympic swimming pools capable of generating enough power for 20 million homes per day in nearby regions, as is the case with the Fengeng pumped storage power station in China, then it may be time to examine the newer styles of gravity battery storage systems. There are roughly two options when it comes to this category, although one company has proposed something a bit different, which we'll see later. Option 1 is the structure above ground, and option 2 is below ground. When it comes to efficiency, they are somewhat comparable to the above ground pumped hydro systems, which operate at a 70 to 75% efficiency rate. The underground gravity storage featuring a hydro pump operates at 65 to 70%, while the gravity energy storage tower has a 75 to 80% efficiency rate. From what I could gather, there seem to be at least 4 companies who are working on securing funding, building prototypes, and in some cases, implementing actual storage systems. These companies are Energy Vault, Gravient, Energozapas LLC, and Gravitricity. First up is Energy Vault, a Swiss company founded in 2017. Energy Vault originally planned on deploying structures consisting of 6 cranes which would lift and lower 35-ton concrete blocks capable of generating 80 megawatt hours. This proof of concept was built, but it was deemed to have a low power to energy ratio, limiting its ability to surge a lot of power to the grid at once. Energy Vault went back to the drawing board after raising a staggering $110 million, which at the time was the largest equity investment for a grid storage system, to say nothing of the fact that it was the same investor who put a hefty sum into WeWork. From their Energy Vault shifted their focus to the G Vault, which is a building 300 to 400 feet high with lattice structure. which, through a series of elevators, raises and lowers heavy blocks of concrete and then slides them into storage on the upper floors when not in use. When energy is needed, the building lowers the blocks, spinning a turbine to regenerate power. In what some consider an amazing feat, Energy has built a full-scale installation in Rudong, China through a company called Atlas Renewable, who actually invested $50 million when the company went public and another $50 million to license the technology and construct the building-sized battery. From the looks of their website, it seems they have another building in construction as well, also in China, this one in Jiangyi. China has invested significantly into Energy Vault and consider these projects new energy storage pilot demonstrations as part of China's dual carbon goals of addressing renewable energy intermittency while also easing grid congestion and connection pains. Looking towards the future, Energy Vault has two very audacious concepts floating around, one which combines residential living with a gravity battery tower, or rather within a gravity battery tower, and another which utilizes a hillside with an array of pulleys that raise and lower weights. Next up is Gravient. Their online presence is a bit mysterious as nothing has been built yet. Their concept involves a rectangular building. The weights move only vertically and are constructed using unstabilized compressed earth block technology held together with recycled fibers. The carbon footprint of these weights is 7 times lower than that of concrete-based weights and 1.5 times more cost-effective. Industrial weight is a main component of these materials, and this includes recycled wind turbine blades. The building is also constructed of steel, which is slightly different than the other companies mentioned as they opt for concrete. Third up is Energozapas LLC. Again, the idea is a system of lifts. A prototype was built in 2018 with a capacity of 10 kilowatts, comprised of 8 shafts or vertical columns connected by horizontal and slanted cross beams located along the walls of the building. The weights consist of durable polymer sacks filled with compressed soil reinforced with geomesh. The next step for Energozapas is to build a full-scale pilot plant in the Russian territory of Skolkovo, 80 meters high, with a capacity of 2.4 megawatts. At last, we come to Gravitricity. Gravitricity is unique in that their system called Gravistore takes advantage of abandoned underground mines to incorporate their lifts into. Termed Underground Gravity Energy Storage, or UGSs for short, it's believed that the number of abandoned mines could globally be in the millions, with 550,000 in the US alone. Also, the closing of mines affects the local communities. By recommissioning these mines, which are typically already tied into the grid, new life and energy are injected. Sand or local materials will be utilized as the medium to be hoisted up and down, minimizing transportation waste of, say, a concrete block, as seen in Energy Vault's projects. The system will enable ultra-long time energy storage ranging from weeks to several years. Many mines are already a kilometer or more in depth, eliminating the need to construct towering new structures. Costs can be redirected to the lowering and lifting technologies as opposed to the structure. It's estimated that abandoned mines can store up to 70 terawatt hours of energy globally, or enough to meet the entire world's electricity needs for a day. Incentives were planned under the Inflation Reduction Act, and we shall see how that pans out, with the idea being that those areas historically dependent on fossil fuels could transition to the clean energy sector. The hope is that not just lower energy costs and the combating of climate change will result, but also broad-based economic opportunity and jobs which sorely need an economic booster shot. In 2021, they successfully constructed, commissioned, and operated a 250 kilowatt grid-connected gravity energy storage demonstration project using a 15-meter high rig at the port of Leith in Edinburgh. Depending on who you ask, I've seen figures projecting energy storage investments totaling $50 billion to $420 billion by the year 2040. According to the Nature Conservancy, the government was poised to offer tax incentives targeted towards helping companies invest in turning brownfields and mine lands into renewable energy hubs. While the cost of retrofitting mines is not without its challenges, especially in the liability and risk department, this is where the U.S. Superfund program can be an effective tool in supporting development. Gravitricity is currently aiming to convert a mine in Finland capable of a 2 megawatt storage. Market uses for gravitricity include industrial decarbonization, energy access, co-location with renewables, and grid services. In another world, it would be great to see decommissioned missile silos also used as underground gravity energy storage. To conclude, by building these energy storage systems close to renewable energy generating solutions whose sources are intermittent and probably do not always coincide with demand, the hope is that these gravity battery systems will have a better long-term cost than the chemical batteries and fewer environmental issues than other traditional storage solutions, like hydro-pumped water storage. With the added feature of being able to quickly provide power during peak consumption, the potential to replace fossil fuel peaking power plants is a reality if the economic will can present itself. Based upon the information the four companies presented, it is somewhat difficult believing that the funding for these projects will fully materialize without an all-out climate emergency worse than the one we currently find ourselves in. If there's a silver lining, it's that at least the research has begun on the problem of energy storage. Thanks for taking this deep dive with me down this mine shaft.